Let's look at an example where administrative distance is going to cause suboptimal path selection. Let's focus right now on just the 10140/24 network, and we are going to perform redistribution on R4 and redistribute that OSPF route into the EIGRP autonomous system of 100. In addition to that, we're going to focus on what happens to R1 specifically here. With the two different routes it learns about for 10140/24. It's going to learn it from OSPF, and it's going to learn it from EIGRP. But we're not going to perform redistribution on R1 here right now. I just want to describe and identify what's going to happen in this particular example, and we're only going to do redistribution on R4. So let's follow right now the purple arrow. Link state advertisements getting sent out, flooded out into what? Our OSPF domain. Eventually R1 receives the LSA. It's going to be an LSA type 1 in this particular example. And it's going to be from R4 describing the particular network. Essentially what R1 is going to do is it's going to ultimately determine how to reach 10140/24 based on Dijkstra's algorithm. And it's going to come up with the fact that 10.1.4.0/24 can be reached via R3, and it has an administrative distance of 110. That's what it ultimately determines. Now, we're not saying this is what's going in the routing table just yet, because we have to look at the example here where we also learned about 10140/24 from EIGRP. So what does EIGRP learn in this particular case if we follow our blue path in this example? Well, if we follow the blue path in this particular example, what are we going to end up with in the EIGRP routing table, or not routing table, topology table? We are going to end up with 10.1.4.0/24 is via R2 with an AD of what, folks? What's the administrative distance going to be here? Now be careful. Be careful. What is happening on R4? On R4, we are performing what? What are we performing? Right, we're redistributing. Redistributing from OSPF into EIGRP. As a result, what is the AD? That's right. It's the external administrative distance of EIGRP now we're looking at. 170. 170. So based on what we know now, is R1 going to choose the OSPF path, or is R1 going to choose the EIGRP path? This decision is strictly based on administrative distance. It has nothing to do with metrics. And that's the first thing our router will look at. It looks through its sources of routing information, finds the best source, and then from there, if there's ties within that source, then it looks at other characteristics like metric for EIGRP or for OSPF. Is it intra area, inter area? Is it E1? Is it E2? Is it N1? Is it N2? In that order. And then OSPF looks at metrics. So there's a lot of processes that the router will go through in order to determine what truly is the best path that ends up in that particular routing table. So here we can definitely see it's the 110 because it's lower. So in this example now, R1, whenever it wants to reach the 10.1.4.0 network, it sends traffic this way. Now, this is definitely suboptimal. And why is it suboptimal? It's suboptimal because of the T1 link. You see the T1 link? 1.544 megabits per second. Wow. Slow. That's right. So we have suboptimal path selection here simply because of the administrative distance. So how can we solve this? Well, what we want to do is we want to make R1 prefer the EIGRP learned information. And we can easily do that by either increasing the administrative distance of the OSPF learned route, or what can we do? We can lower the administrative distance of the external EIGRP learned route.